What do you do an inverse function? On the table, you switch the x and y columns. For a function, you switch x and y. You make your x into y, you make your y into an x. You just switch x and y. Understand that in terms of what we did with the basic graphs. That's how it was explained. And that was an exercise, okay? So if you didn't get it from the basic graphs, go back into the basic graph. You need to really understand these graphs. Okay, so you have this. Now, we want this as a function of x, y as a function of x. We got to solve for y. So we have x equals 1 over y minus 6. We multiply by y minus 6, but we can't multiply by 0, so we have to say y can't equal 6 because then we multiply by 0. Okay. So we multiply by y minus 6, we get y minus 6 times x. 1 over y minus 6 times 1 over 6. So x and y, this is x times, no. I want to write this as xy minus 6x equals 1. And it's y minus 6 is y minus 6 over 1. So this can be arranged as y minus 6 over y minus 6 times 1. So this is 1. Then xy equals 1 plus 6x. Adding 6 to both sides. And then divide both sides. By x, noting that you can't divide by 0, so x can't be 0. We get y equals 1 plus 6x over x. Perfectly good rational function. We could write that as 1 over x plus 6. And we could easily graph this. It's just a basic reciprocal function raised to 6 units. That's the process for doing an inverse function. Now we've done this in class. Algebra is really steep, so I didn't emphasize it too much. You don't have to do algebra now. You have to do this with a rational function. So let's try the inverse. Of y equals plus 3 over x minus 7. Now the algebra steps are similar. First, we x and y. That's what we do for the inverse function. And then we solve for y. And so multiply by your denominator, y minus 7. So y can't be equal to 7. And you get I'm going to include all the steps where I want you to. Okay, you get this. Now we've got to get all the y's on one side. And we Can't really do that. This y is tied up inside the parentheses, so we can't really do that until we use a distributive law here. Now we've got everything where we can put everything that doesn't include a y on the right-hand side and everything that does on the left-hand side. So we get again, there are algebra steps in between that you need to understand. What I want to do when you write things out. We get x, y minus y equals 3 plus 7x. So we have all the y's on one side, but here's where it gets a little tricky. Everything that we've done up to here is fairly straightforward. How are we going to isolate y when one of the y's has an x in front of it, the other just subtract it? Well, we factor out y. And that's a step that's a little bit hard to remember. So we get y times x minus 1 equals 3 plus 7x. Then we divide by x minus 1, where x can't equal 1. We get y equals 3 plus 7x over x minus 1. So we can say f of x function is x plus 3 over x minus 7. F inverse of x function should then be 3 plus 7x over x minus 1. So you're not going to really understand it unless you then test whether this is really an inverse function. So the inverse function is a function that undoes the original function. So if you start with x, then do f inverse, and then do f, you should get back where you started from. Where do you start? You started at x. We'll check and see if that's true. Well, f of f inverse of x. F of x is x plus 3 over x minus 7. So f of f inverse of x is f inverse of x plus 3 over f inverse of x minus 7. Question mark over this. I'm trying to determine if this is equal to x. Here's where the algebra gets a little more complicated because we have to have a complex fraction. Okay. F inverse of x itself is 3 plus 7x over x minus 1. Then we have to divide that by f inverse of x minus 7, which is okay. I'm not sure we see what I just wrote very well. I don't have to load the thing around that I was using before. I've got this sensor camera here. It'll actually zoom. When we see that, come on, focus. What are we gonna do about this? Well, we're gonna multiply, we're gonna use a common denominator here. We're gonna use a common denominator down here. Look at this expression, the common denominator has to be x minus 1. So we're gonna have and we multiply 3 by x minus 1 over x minus 1, so now we're going to have a common denominator of x minus 1. Down here in the denominator, we do the same thing for the -7. So now we have running out of room. Um, and 3 times the x minus 1 gives us 3x minus 3. Here we have 3 plus 7x, so our 3 plus 7x, 3 times the quantity x minus 1 is written this way. And in the denominator, we have 3 plus 7x minus 7x plus 7 over x minus 1. Seems to be working out. Never mind, it worked out. Okay. Now the numerator here is 10x over x minus 1. And the denominator here, the x's divide out, and we have 3 plus 7 is 10. Okay, well, I'm out of room, but over here. Make sure. Yeah. Okay. After this step, multiply 3x, 3 times x minus 1 to get 3x minus 3. That becomes part of our numerator. -7 times x minus 1 gives us a -7x plus 7 in our numerator of this denominator expression. And then when we add all this up, we just get 10x. When we add this denominator up, we get 10. So now what do we have? We have an x over x minus 1, all that divided by 10 over x minus 1. And let's see if that equals x. So that's just 10x over x minus 1 multiplied by 10, x minus 1 over 10. And we know that equals that. So, well, that's just 10x over 10 times x minus 1 over x minus 1. X minus 1 over x minus 1 is 1. 10x over 10 is 10. We get x times 1 equals x. X equals x. And now big check mark. We just tested whether alpha beta inverse of x equals x. Now, there are a lot of steps there. You have to understand the function notation. You have to be able to do the algebra. But this is a fairly typical problem in the upcoming assignment. So hopefully you were paying attention last time I worked through the inverse function of this nature, so you understand this function. And hopefully you understand function notation well enough to set up this equation and then understand how to do common denominators and so forth well enough to do this. It's a fairly complicated and fairly detailed series of calculations. But we need to be able to do this. Back up this single hole. Over a little bit.